Hello and welcome again to Racecraft. I'm George May. This time I'm going to show you how to narrow a Jag rear. Now the way I do it is by no means the only way to do it. But I've done quite a few of these over the years and I find that this system works. So that's your typical Jag rear lower control arm. We'll be cutting this and narrowing this down. This is your drive shaft. I'm going to pull the universals and everything out of that, and then I'll show you how to shorten that up as well. Now, here's a shaft that I've already taken the unis out of. The only machined surface on this is where the unis go, and these two centre holes. Now, these little centre holes are very important because they're the true axis of the shaft. But the shaft itself is just rough cast. So we're going to put that in the lathe between centres, and I'm going to turn this surface down to get it nice and smooth so we can cut it and shorten it. So we'll go and stick it in the lathe. Now in order to put this between centres, put a piece of steel in the lathe, turn a point onto it, the same angle as a centre drill, your rotating centre in the tailstock, and pop that in between centres. Now I'm just going to pop that in there now. Wind that up. Now what you want to do is set it up in such a way that the chuck jaw comes around and hits the end of the universal, or the universal flange on the end of it. And what that'll do, although this is between centres, is that will drive this shaft for you. So I'll go ahead and I'll tighten all that up and I'll start turning the centre of the shaft down. Alrighty, so I've got my shaft turned down here, nice and neat. You don't want to take too much material off because all you want to do is clean it up so that when you put it into the tube that you're going to weld in, it's nice and true and it will all run true. Well, I'm at that stage now where I've got my shafts turned down. I've cut them, so now we've got to join them back together again. And to do that, I'm going to slide them inside a tube and weld them on. However, this is the important part. You can't just weld them straight into the end of the tube like that. If you do, it's going to break off next to the weld. Most likely break off next to the weld. And the reason for that is because you're concentrating all the stress in one point. And to demonstrate this point, here's a shaft that somebody else has done, and what they've decided to do is just to weld the shaft back together again like that. Now, this came out of a rear end that I bought, which was all in pieces, and judging from the amount of damage on it, I'd say that possibly one of those shafts has actually failed and then had a catastrophic failure in the rear end. I don't know that for sure, but it'd be a fairly good guess. So what you've got to do when you've made your tube that you're going to put the ends in is to V out the end of it. Now, I've just milled that off in the milling machine, but you can just cut that with a disc on your grinder. But it's very important to make sure that you V that out. Now, the reason for that is that if you took that shaft there and you measured that weld, how far around that weld goes. If you remember your schoolboy arithmetic, the circumference of the circle is pi d. So it's 3.142 multiplied by the diameter. So if we round that off to 3, this is about 30 mil in diameter. So 3 3s are 9. So you've got about 90 millimeters of weld going around in that circle. So if you took that weld and you straightened it out, it would be about 90 mils long. So using that, if we look at this, you've got about 60 mil just going down one side there. So 4 6s are 24. So you've actually got 240 mil of weld joining your shaft onto your sleeve. Very important, because that spreads the stress over a much greater area. And it also spreads the stress at an angle, not just in one little round ring. So important that you V that out when you weld it together. Now in the vise here, I've got one ready to go. I've measured the distance in between to make sure that it's the right width that we want. So now you've got to align the two halves to get the two universals dead in line with each other. And that's fairly simple to do. All you need is a couple of nice straight rods. You pop them in there into the universal, one in each end. And all you need to do is now sight along both of them. And this works remarkably well. You'll be surprised how little you've got to move them to see how they line up. So I've spent a little bit of time lining that one up. A little bit out, just needs a tiny little tap on this side here. Well, a little bit too far. You can see what I mean. It just takes a tiniest little tap to get it lined up. That's pretty good. So what I'm going to do now, with that nicely lined up, is I'm just going to tack the two ends. I only tack them because this needs to have, because it's high tensile steel, it needs to have a preheat before you fully weld it. So I'm only going to tack that in each end, and then I'll fully weld it. Just gently take those out of there, hook up the welder, and I'll tack them in place. Right, so I've got the first one tacked in. Now, to do the second arm, here's a good little trick. Use the trunnions, the bearings off your old universal joints, and pop them just halfway in. Just like that. Then, when you take your other arm, which you can still move, pop it on top. There we go. Tapping down. There we go. And what you've done now, you've used these two cups as dowels to dowel the two of them together. So you now know that both of these are exactly the same length. So we measured the first one, make sure that was exactly the length I wanted, put the second one on top, job's done. Now, with a pair of vice grips, which I had here, if you just clamp those two together, which a bit of vice grip here, just clamp those two together. Okay, that's that. Clamp this side together as well. Okay. Now, because these faces here are square and machined, by clamping that one to that one, it's also now in alignment because it's lined up by the other one. So not only have you got the same length, you know that it's lined up correctly as well. So all I'm going to do now is tack this one together, and then I can preheat and fully weld them. So just a quick weld now. A little bit of anti-spatter just to keep them nice and clean. There we go, it's done. So let's take this apart and we'll get on to the next bit. This is a typical Jaguar arm. This is one of the components that's going to have to be shortened up. Now, it needs to be cut. When you cut it, you want to cut it where this weld here is. But you want to cut it on the arm side, this side of that weld. So you can see that little lump there. You want to cut it on the inside edge of that little lump. That's actually a weld. How I think Jaguar welded these together was ERW, electrical resistance welding, which means that they pushed the two tubes together with a current in each one, forced them together, and they welded. The reason that you want to cut the weld off is because you're cutting the arm anyway, so you're going to cut the weld off. Now, this is one that I've cut before, and you can see that it's a pretty ugly looking weld in there. There's a lot of excess material in there, and because you're going to have to machine this bore out to put a sleeve in there to sleeve the two together, you don't want to have to be cutting that with your boring bar. So if you cut it through there, cut it off, then you can just throw that ugly welded piece away. If you look inside here, apart from the rust and the scale in there, it's a pretty good diameter. So this is going to go in the lathe, and I'm going to true up that inside diameter, then put a bush in it, and the bush is going to align the tube and this arm back together so I can weld it. Now when you look inside the tube, you can see all this roughness inside here, all these little bubble-like structures and so forth, and that's the weld. You can see the little bit of space there. That's where it's been welded. Now the reason that you leave the weld on this side is because you're going to cut the tube anyway to shorten it up. So I've got to take about 55mm off the end of that tube, then I'll set that up in the lathe, turn it, make the inside diameter nice and true, and then we can slide the bush inside that, inside the arm, align the arms, and then weld them back together again. Alright, so what I'm going to do now is we're going to turn this inside diameter nice and true so we can press our sleeve in there. I'll also face that area off so it's dead square. So then when we put the tube on, it'll be machined out inside as well. I can press it right up against that face and we'll be dead square. Now, the trick is in how to hold this. Now, I guess you could somehow hold that with your 4-jaw chuck and put a dial indicator on it, because that is actually a machined face there. I've found another way to do it, maybe a little bit sketchy because you don't have a great deal of grip, and that is to put the little chuck in the big chuck and then use the jaws to go into the back, into that machined diameter. So that's how it ends up looking. And then if you're careful and take light cuts, you can machine that inside there. If you go in too hard, obviously the tool's going to bite it and you're going to spit that out. But I hate to think what this would do if it got spat out. Anyway, that's how that bit's done. The pipe section of it's a little bit more difficult, but I'll show you that in just a sec. We'll still be using the little 3-jaw chuck though. With the pipe side of it, I haven't cut this yet in the bandsaw, but I'm going to cut the 55mm that he wants off it, cut that in the bandsaw. But just to show you how it's going to go in the lathe, it's still going to go in with the little 3-jaw chuck, but this time we're going to support it with the 3-point steady here, so quite a bit safer. So what I'll do is I'll bring the big cone center up to that to centralize it, then adjust these up so it runs nice and true. Then I'll be able to face that off, get it all nice and dead square, and also machine down inside and just true up that diameter. So when we put our sleeve in, it'll all line up nice and square. Anyway, I'll do some machining and I'll show it to you once it's done. It's been about 3 or 4 years since I've had to do one of these Jag rears, and it's quite funny that this week I've got 2 of them to do. So, like they say, comes in pairs, or is that in 3s? Anyway, we're on to the lower control arms now. So what I've done is I've machined the inside diameter of the tube there. Only just a skim, you don't want to take too much material out, it's only just a skim. I've made up the little sleeve that's going to go into there. So I'll tap that in just a moment. And I've also done the outer end, or actually this is the inner end, the end that goes towards the diff. So I've done that as well. When you do that, make that sleeve still a neat fit in there, but give yourself enough so that it'll be able to rotate fairly easily. Because what you've got to do, just like the drive shafts, is you've got to get these 2 halves lined up correctly with each other. So once again, we're just going to put the rods inside and sight through them. So when you're ready, when you're at that point and you've put your sleeve in, you've put the end on, you need to pull the 2 ends together. Now, because when I had this in the lathe, I machined that end dead square with the end of the tube. I did the same with this. I've machined that area there dead square with the inside diameter and the outside diameter. So I know that's square. So when those 2 touch each other, this should be nice and square. So in order to hold the 2 of them together, pretty simple. Bit of rod, just a threaded rod. It has to be relatively small in diameter because you've got to get past this tube that's welded across the lower control arm. So I've got a couple of these big washers here. Actually, these washers, I use the dropout part out of the hole saw when I hole saw a big hole into a bit of sheet metal. And I save these washers because they come in handy exactly for this sort of thing. So pop that in there, pop the washer on, nut on, and just nip that up. So that'll pull that nice and square. So I'll pop that in the vise now and we'll start squaring it up. Now when I cut this arm, I marked which way around it goes. So be careful that you don't get it upside down because that would be tragic if you did. So I marked the upside, also marked O's on this one, X's on the other, so I don't mix up the 2 arms. So I've nipped up the nut in the center there. So now it's just a matter of popping our tube in to here and here. Better stop there. So I've got my 2 pieces of rod in there. So now I'm just going to sight along the 2 of them and get the arms nice and square. A little bit more yet. It's getting close. That's pretty good. That's pretty good. All right, so what I'll do now is I'll just tack that. All right, so it's tacked up, can't move. All right, so I'll put the next one in, do exactly the same, and then I'll just go around and fully weld it. So just the same as the last one. I'm going to put my piece of threaded rod through here, pop the washer on, and nip it up. Got my X's up, so I know I'm lined up. And once more, put my rods through here. And that's it. Now I'll just side it up again, tack it, and then I'll be ready to fully weld it. So that's about it. That's roughly how I do it. Like I say, there's plenty of different ways to go about shortening a Jag rear. Over the years, I've found this system works really well for me. With the top drive shaft, you can shorten the shafts and weld them, or you could get a tail shaft style tubular arm made for the top. The tubular arm on the top is probably the best way to go, but they are expensive as well. So if you're on a budget and you're trying to do this for the minimum outlay, then this is a good way to do it. When you're preparing these lower control arms, one thing that you must do is to V out the tube. So when the two halves go together, you've got a nice wide V in there for your weld, so you get good weld penetration. Now in an ideal world, once you've done that V out, your penetration should go through and actually weld to the little sleeve inside. So then your two halves will be welded together and also welded to the sleeve, which will make it super strong. So make sure you V it out before you weld it. So if you're doing a Jaguar conversion, you're probably putting it into some sort of different vehicle other than a Jag. So the Jaguar runs Chev or Holden pattern, not Commodore, but the Holden like HQ. So you may have to end up changing the stud pattern. It's good because you can drill the pattern in between these other studs, but you do have to get the studs out. Now Jaguar uses an interesting method of putting the studs in. What they do is they screw the stud in and then peen the back of it over. So it's screwed in and then peened over. So getting them out is a bit of a challenge. So what I've done is I've put it in the lathe and I've just machined the back off. So all of those little raised edges there where it's peened over, they're all gone. Now, you don't have to do it in the lathe. If you get your angle grinder and just grind that smooth with the back of the flange, that will do. So once you've done that, what you can do, what I've done, is I've got some old wheel nuts. Now, just for ease, I've actually drilled a hole straight through the wheel nut, so it just falls straight onto the stud. So pop those on, then I've welded them all on. Now, the reason I've welded them on is just to make it easy to get them all out. So now that they're welded on, I'll just pop this in the vise. Get the trusty rattle gun, and with any luck, I'll just unscrew. Well, as you can see, we've got one really tight one there, so I might have to get the breaker bar onto that, get that out with a breaker bar. But usually they just unscrew. No, definitely not coming up. But you can see there, you can see the threads on that, and you can see a little shoulder there where it locks up against the hub. So once I get that last one out, I'll set that up and I'll drill the forward pattern that this particular guy wants in between those other studs. So I've got the arms welded up now, and what I've done is I've put the arm back in the lathe and I've dressed the weld. This is just for appearance. You don't really need to do this. If you want to dress it up, you don't want to put it back in the lathe, you don't have a lathe, you can always just go over it with the flat disc in your angle grinder. Now, the arms, sorry, the drive shafts, I've also welded the drive shafts up, and I've also put those back in the lathe. Now, the reason that I've remachined these is because I put it back in those center holes that I showed you earlier on, and then just taken a light cut off the outside. Now, the reason for that is these will probably never get balanced. So I want them to run dead true. So by putting them back in their original center holes and just taking a little light skim, I know that when they're in the car, they will run absolutely dead true. So that's about it for shortening a Jag Diff. Hope you've enjoyed the video, and thanks for tuning in.